Okay, so last class we talked about the basically how computers interact between each other over the network. It was really just a very simple overview of how that works. Today we're actually going to start more of the actual topics and curriculum, how Cisco would actually teach it as far as topic by topic. The main topic today is OSI model. Okay, that would be this guy right here. Okay, so this is the OSI model. Basically, it is explaining how information is sent from a computer, from the computer's perspective, and then from the computer technician's point of cognition or point of understanding how it works as far as processing. This is what you would use for when you're doing troubleshooting. This is kind of like a troubleshooter's checklist if you're actually at a computer and it's not getting connectivity. All right, so basically, I'm going to start with, I'm going to go from the bottom up. So basically you have layer 1, which is your physical. This would be the equivalent of your Ethernet cords, fiber optic cables, all of those, that is physical. This is stuff that's going to carry electrical signals. That's one important word there. So if you think of anything that's carrying an actual electrical signal, oh, by the way, there's some pizza over there, lots of food. So this is basically talking about carrying electrical signals, anything that's directly connected to one another. That's physical. It's pretty self-explanatory. This one here is called the data link, which provides connections between hosts on the same network. So this is your Ethernet MAC address. Now, we didn't talk about this last class. And basically, when you say MAC addresses, every computer has a NIC card in it, which we did talk about, which is your network interface card. And this card is made by a manufacturer. And this manufacturer puts this card in your computer, and this is what allows your computer to take Ethernet cords. Or it would be equivalent to your wireless card in your computer. Wireless cards have NICs on them as well. Okay. So when you get that card, each card has its own unique MAC address. Okay, that's not your IP address. This is a MAC address. You can call it your hardware address. It's similar to that. It's almost like a serial number for that card. Okay. MAC addresses have basically, you know what? Correct me if I'm wrong, because I actually don't remember where the number is, but I don't remember the actual format. I think there's 6 of them. Yeah, there is. I'm sure. Okay. So basically, that's how your typical, right? Isn't that 6?
Yes, sir.
6 MAC address. 6.
Yeah.
Okay. So this is basically how your typical MAC address is laid out. You have the first 3 right here. This represents the number that the actual company is given. Okay. By internet standards like ICANN, that would be an internet company that would give out that set. So basically, these right here will identify the manufacturer. Okay. And then this back here identifies the manufacturer's card. Yes. I can see it. Okay. So yeah, so basically, this here, for instance, if Intel was making the card, they have their own specific range of numbers they can use. And this is numbers and letters, okay? This isn't just numbers, it's also important to know. They have their own range that they can use. That identifies them. This part identifies the card. So that's what it means when this is MAC address. MAC address is used by hardware on the network to know how to send information. That's when we start talking about switches. We'll learn more about the MAC address. So that's how you know what this is. That's why it's considered hardware, because the MAC address directly relates to this NIC card. If you change the NIC card, you're changing your MAC address. There are ways to spoof your MAC address, which means change your computer's interpretation of the MAC address and keep the same NIC card. That's like for covering your tracks and stuff like that. A lot of hackers and people do that kind of thing. So we're going to move up to the next one, which is the network layer. So this network layer here, what connects some different networks. So this is where your IP address is coming. Okay, so this here, basically, remember how I said MAC addresses are used with switches? Switches are connecting computers. Switches, we call them not smart. They have smart switches out now that are basically switches and routers put together. But typically, we're going to refer to this class, the switches as not smart. So basically, switches, they just look at MAC addresses, and they can send packets to other computers directly connected to them, pretty much solely based on their MAC address. That's how they figured out. We're going to go into depth on that when I talk about switches. But as soon as you jump to another network, for instance, in the last class, when you go outside your network and you have to go to that default gateway, that router, he's looking at IP addresses. Okay. He also can see the MAC address, but he's more looking at the IP addresses. That's how he decides where he's sending stuff. Okay. So this is where, and you see here routing of all data packets here. That's where address. We got into that. Not IP addresses on this. So the transport layer. This one is all computer stuff. You see, this is all software. This is heavily computer stuff. I'm not going to get into it because this is a topic on its own. But basically, you're talking about different protocols. Okay. So you have transport.
What's that?
TCP.
Transport control protocol and user data protocol.
And user data. Okay, so TCP and UDP. Now TCP is basically what's always used for data communications. It's reliable in the sense that this is the protocol that tells the computer, okay, this is the information you're getting. This is the protocol you apply to it so you can understand what it is. Okay. This guy is another version of it. He also does the same thing. Hey, this is the information you're getting. This is what I am. This is how you understand me, basically. This guy is typically used for video. So this live stream that's happening, probably using, I'm sure it's using video. It's all video pretty much, yes.
I actually want to touch on TCP versus UDP. So with TCP, it's connection oriented versus UDP where it is not. With TCP, it relies on computers receiving and acknowledging that they've made and received that packet, whereas UDP just throws the information at the computer printed out that it gets the information. The upside to that is if you're on like a voice over IP call or doing video calls, you don't want your computer slowing down to acknowledge that it's received that packet. It just wants to throw that information and get it to you as fast as possible. Where UDP is quicker, that's why we use it for video and audio. It's not going to rely on that handshake acknowledgement from there.
Exactly. So yeah, so basically, like I said, when we get to this topic, the class of this, we'll go very in depth and actually will show you, and I'm also going to show you the software we're going to be using. This is the software you will be using too, to actually learn this stuff. I'm going to show you that. And with that class, we'll use that software to explain this and how this works exactly in an extreme amount of detail. It's actually really cool. Well, maybe it's cool. I don't know. So this is your session layer here. Okay. This is session 5. So this controls the dialogue between computers, controls termination, and restarts. This again is another very specific part of the OSI layer. This is all happening in your computer. This one we're also going to talk about in depth. It's going to go with this one. So I'm really going to skip over it. I'm not going to talk about this one too much either, because these two are really behind the scenes stuff. So I'm going to go to the presentation layer. This here is the context for communication between layers. Basically, this is the closest to you being able to know what's happening, aside from this up here. So basically, if you have, let's go with Google Chrome, Firefox, whatever, you request a web page, you're sending a request for a document file, .html, that file. That file has a whole bunch of lines, code. You may have seen it before TV or even in web classes, or if you're in a web development class. And you're getting that code, and your computer knows how to interpret it into pictures and websites and all that you see. This guy is what helps with the actual formation of that stuff and presenting it to you. Okay. So this one here is not as complicated as the others, but also it is one of its own guys. So really, all of this here is very closely related. But this here is what you see. This is your responses. This is everything that you're getting stuff back, okay? Application and presentation work together very closely. Hence the names, I mean, it's pretty, kind of kept it pretty obvious. There's actually another model, I'm not gonna get into today, that is, it's kind of the same type of stuff. If you lay them out side by side, you can see the resemblances, but they categorize them differently. We'll go over that model too, but we'll go over that later, because this is the main one. This is what I was talking about, so I consider this the main one. People argue that all the time. This is the main one. So application, as you can see, high level, meaning it's in front of your face, it's there. When you get on your computer, this is what you're seeing. This is your HTTP. This is the website that comes back. This is what you're seeing. This is FTP. These are the files you download. So when you go like Netflix, you don't directly download and save it, but you are streaming it. It is downloading. That's what you're seeing. SMTP, your email, that's directly what you're seeing. Okay. So that's kind of how this OSI model works. And just so you understand why it's important, this is how you would troubleshoot if you're having an issue. You can do what we call a top-down approach or a bottom-up approach. Basically what that means is if I have a computer that can't connect to the internet, if I'm going to do a top-down approach, let's go with that. First, I'm going to go Google Chrome, type in a website. It comes back, can't find the server, whatever. All right, so this guy's not working. I'm going to go to the next one. Presentation. I use command prompt or something for this guy and just kind of see if it can actually accept any type like ping. I use ping or something like that. Ping actually works straight through in conjunction all the way up here. But it's really, ping is pretty much what you use for all of these. It gets results. Have anybody familiar with what I'm saying? Ping, let me say it. No? Okay. So ping, really cool. I'll actually show it to you. Just give me a second to flip this guy. Yeah. Entire screen. Share. All right, this is like my first time using this. Whoa, look at that. All right, so I'm gonna open up command prompt. All right, so basically ping is a network tool that a lot of technicians use to test connectivity. It's pretty much really it's the only reason why I've used it. So basically you just go in here, you can type in ping right away, and then you type in IP address. So like I said, if I'm on a computer that we suspect is not able to connect to the internet, basically I can go on there, come here, type in an IP address. I don't know the school's IP system, so I don't know their IP addresses. You can also type in names. So I'm gonna type in, wow. Okay.
Type in 10.
Okay.
221. 80.1.
I have no clue what this is. This was fun about it. Okay. So you see here?
That's the router of the school.
Oh, there you go. So this is actually the default gateway that all the computers use. Router, default gateway, get those same. Okay, for all intents and purposes right now, same. So this is, I should have put that lower. This is a reply for ping. So this computer is connected to the internet, that's why I got replies. If it wasn't, it would say, cannot connect the host or something. Like I'll type in one word, it's gibberish, and we'll be able to figure it out. So this is a reply, that means that it's working. You see it says, I got a reply from where you sent. This is what they sent, this is what I sent. These are just pretty much the bytes, it's not like real data, but sent that, this is how long it took. And then this is, okay, this is protocol, I'm not gonna get into that. Anyway, so you see that it's sent packets, sent 4, received back 4. This is working, actually not on TCP, but I can use this for a good example of that whole handshake thing he was talking about. You can see he sent one, and one came back saying we got it, and sent another. It's kind of that handshake thing. You see that a lot, even though this does not use TCP. But again, that's another topic. So this guy works. Let me find an IP address that won't work. So I'm going to do ping again. Maybe the school's not using 50. I don't know what they're not. Let's see. Oh, this one's not working. Perfect. So you'll be able to see request timed out. Request timed out. It's going to do it 4 times because it sends 4 packets. Tries 4 times basically. Request timed out. So this means this computer is not working. So now I know basically. Let me flip this again real quick. That is disgusting. All right. Right. Okay. So now we know basically that that computer is not connected, it's not working. So I basically, in that, was able to test pretty much all of these, especially the IP address, because that's what I use in order to communicate. All right, so now data link, say I finished on my okay, maybe it's not plugged in. If I'm talking about data link here, then I'm probably gonna look at the back of the computer. If you look at the back, I'm sure you've seen it on your computers before at home, there's blinking lights. Okay. There's two of them. One light indicates connectivity, and the other light indicates that there's actually packets going through or electrical signals changing. That's pretty much the fluctuation that's packets being sent through. Okay. So if I see no lights, if I see no green light's usually always dead. That means that there's no electricity on the wire. The wire's dead, something's happened with the wire, probably cut, whatever. If I see the orange light not blinking rapidly, then that means that there's no communication. Now, not all the time is the wire blinking, because sometimes computers actually aren't talking. Most of the time they are, sometimes they're not. So that's not always a good way to tell, but that's one way to tell. So let's just say for all intents and purposes, it was blinking, or you can actually have it blinking in communication, and all of this stuff still fail. All of that we'll learn back later, because that means that you have issues with your IP address setup. It could be your router setup, but you are still getting information through the port, and you are still getting power. So it can still show you green light and rapid blinking orange. So here, physical. That's what is it plugged in? You've heard that from computer is it plugged in? That's this, because it's physical. Or is the cable completely severed? That's also considered physical because it's not plugged in, essentially. Okay. So that's the OSI. Again, we will be going back to this throughout the entire computer networking course. This is fundamental type 101 type stuff. Now I'm going to go to packet tracer. Okay. Okay, there we go. Yep, that works. All right, so this here is the software that we will be using. You already bring your laptop, so it's good. You will need your laptop for this. Mac or PC is fine. Doesn't matter. No, you will not be able to download this. You'd have to connect to a server and pull it up remote-wise. We'll provide that for you. So basically, now I'm just kind of showing what in the diagram world different devices look like. So this is a router here. This here is a switch. Okay. This here is a hub, which we haven't even referenced yet. We will later. Yeah, right. This here in this world is a wireless device, wireless access point. Let me get that right. This guy here, I'll explain what he is. Give me a second on him. This here is a PC. Okay. This here is a server in this world. Let's see. That's pretty much it for all as far as what we need to go over. So. I'm sorry? This is called Packet Tracer. This is a program made by Cisco that allows you to create virtual networks and test your abilities as far as using their hardware on their software, which they actually call it the iOS. It's like Apple, but it's called iOS. They have it before. So Apple's integrated operating system. I'm sorry? Integrated operating system. Yeah. So that is where the name comes from. But yeah, they have this called the iOS. That's their command line interface, which I will show you later. Okay. So this guy here is a router. You can tell these. You can't see it too well up here on this. You might be able to see on the TV. There's arrows pointing in different directions, representing data going in and out in different directions. This guy here is a PC, basic end user is what you call them, where data goes to, request from end user. This is a PC. This guy's a server. Okay. This guy's a switch. You can tell he's a switch. Again, I don't know if you can see the arrows, but they're going parallel but facing different ways. That is a switch. Okay. This guy's a hub. The only thing that really defines him is he looks like weird, so he's a hub. This guy's an access point. His definition is the waves representing Wi-Fi, stuff like that. Okay. This guy is what you have in your house, most of you. This is a router and an access point put together. Okay. That's why he has antennas. There is an acronym for them. What? Nobody text me. There's an acronym for. I don't remember. I'll find it out for you. But basically, it is what you have in your house. It does both of these two guys' jobs. If you look on a server rack, like in a business or something, you're going to see, and we're actually going to show you. We have some, or he actually has his. and he will bring his router, and I think it's a switch too, and he'll show you what they actually look like. Basically, they look like boxes. And the in-apps is funny. They look like boxes, and they mount onto a rack, okay? Routers in businesses, routers for the school, definitely does not look like the one you see in your house. It's a little box with antennas. That's that guy. That's what that guy's representing, okay? He's like, they call it a multifunctional router or something. There's an acronym for it. I just don't remember.
I'm honestly.
It's something like that.
I've always just.
Yeah. My teacher gave me the official terminology. He said in a real world, you'll never use it. But he was like, I have to tell you. So anyway, this down here, what? Hide. Okay. This down here is basically the different types of connections that you can use for connecting devices. You will learn about these connections once we start doing the hands-on with this. Probably won't get the hands-on with this software till probably about 3 more classes, beginning of next semester, because guess what? There's like 3 more weeks, something like that. So anyway, that's that. But yeah, these are the different connections. This software is very powerful. I'm gonna see if I have any. No, I don't. I was gonna see if I had any like test environments that I made before to show you. It's pretty depressing that I don't. Maybe this one has the samples. Ooh, look at this. Let's see. No, okay. No samples either. So maybe next class, we won't do hands-on with this next class, but next class I will create an environment. And that way you can see what it actually looks like when it's all connected and working. It's really cool. So yeah, so that's what this software basically is. Bye-bye. Go away. Okay, so with that, we're actually going to go on and start his portion, which is about servers, okay? So,
My turn?
your turn.
Cool.
Let me pull up your PowerPoint. Wait, is this? Yes, okay.
And you know, I upgraded my computer to Windows 10.
Ooh,
I have all sorts of driver issues.
driver issues, really?
Yeah, I upgraded all the latest drivers, and just the school Wi-Fi just keeps jumping me off the network. It's like I can't maintain the DHCP loose.
Oh, that sucks.
Like I could even get into like updated.
I'm working on it. Yes, I'm not entirely sure if it's a Windows 7 problem or my driver problem.
Okay, you
cool.
need to see here to click there?
Oh, no, it's fine. I can get it. It's not right here. So, very, very basic. Just starting you guys out today with installing Windows Server 2012. Oh, yeah, Martha, cool. Thank you. So, I'm not really going to go over anything too heavy. The next chapter, I would like to talk about deploying Windows Server. So, like, there's not one technician going to every single computer, dropping a CD into a drive and installing Windows Server. That's stupid, and you're going to drive yourself crazy doing that, and you might actually get fired in the process. So, I'm actually going to just run through the basic installation of Windows Server, and I'm going to teach you how to deploy that in a big network next time. So, very basic, we're starting. So, a couple of things about Windows Server 2012 R2 is it's got some new features. We have storage spaces. We have BitLocker. Now we have a lot more tools at our disposal for helping us manage networks. Now, this is a list I put together of all the different roles and features. If you guys want to read about it, I'll go over very briefly what they are. BitLocker, they kind of just, I'm not going to read it for you because you guys can do it.
Give me 1 second. I'm going to share the screen so that way people could, when you watch the video, you can actually, it makes more sense to do it that way.
Sweet.
Okay.
Cool. Awesome. So, Windows Server 2012 is, and pretty much every Windows server is made up of something called roles and features. Roles decide what the server does, its role in the network, and features are sub-pieces of software that allow it to support that role. So, a couple of the roles here. Active Directory domain services is a huge one. You're going to see that come up a lot. If you go to the library right now, you can log in with your account on any one of those computers, and you can get your documents. That's Active Directory at play. Active Directory is what's allowing you to log in on those computers. And the benefit to a system administrator of having that is we can provide secure authentication, single sign-on. It really makes our lives easier. So you're going to see Active Directory come up with a lot because I come up a lot because it just allows easy maintenance of all your users and your computers.
If I may, you will actually physically set that up.
Yes, that is a huge one.
Because that one is like the premise of everything else, like it makes everything else work. There's no network that uses Windows stuff that doesn't have this implemented. So you actually each, whoever, will each set it up.
It is actually funny he mentions that. So more features, DHCP, DNS, these are all networking terms that you're going to go over with Travis when he gets to them. But this can function as a DHCP server, DNS server. You'll get to that. That'll make much more sense. If you want to write it down or whatever, you can read through it. Let's go over more roles and features. Okay. So this is the one I was talking about right here. With deploying Windows Server, you're going to use a tool called Windows Deployment Services to do that. And that's going to be a huge tool in the process of deploying your Windows computer. All right. So this is actually the slide I wanted to touch on. So when you come to Windows Server, there's a couple different installations that you can do of Windows Server. So you have your GUI, your core, and your Win shell. So when you install Windows Server, if you want to install it with a nice desktop, like you have icons, mouse, and keyboard to control it, you can install that with the GUI, or you can install Server Core. Now this is actually a test tip right here. Server Core is new. That's a new feature in Windows Server 2012 Part 2 that you could not do with other previous versions of Windows Server. That's important. It actually can give you an extra layer of security, all right? So I want you to imagine somebody waddles into your network that is pretending to be an authorized user. If he gets confronted with a shell instead of a GUI, he may not know what to do. Plus, it can actually decrease the overhead on your servers. So it's more resource friendly and can actually allow your servers to function better. Because now they don't have to work with a desktop. It's not using up those resources. So Core is actually very helpful. And there is a huge difference between GUI and Core. You can't run everything on Core that you can run with the GUI. And very, very important, also another side note, is that the GUI, the graphical user interface, the nice, pretty desktop, that's actually a feature in Windows Server. So you can uninstall the GUI of Windows Server and reinstall it back on if you want it. So, a couple things in the Win shell. If you install direct Server Core, you're not going to have the option to reinstall the GUI as easy. Win shell includes some of the prerequisites required. So. But mostly you're going to be focusing on the top two. All right, so Server Core, some of the roles that Server Core can do. We'll really dive into this when we get into configuring the server. You're going to see the differences. I'm not going to really harp on this too much. Again, this is just a very brief introduction to Windows Server. I'm not going to make you guys remember this. I don't expect you guys to remember this list. Because once you start to configure the GUI and you start to get into Windows Server, it's going to become very, very apparent the differences. And it's going to make more sense to you. So this is what Server Core can do. Part of the list. Okay. So when you have a client that wants to run a Windows server, you have to know exactly what you're up against. And these all cost ridiculous amounts of money, but some of them cost a little bit less, so you have to be wary of what you're going to purchase. So starting out with Foundation, it's exactly what it sounds like. It's a very, very small basis of Windows Server. It's extremely tiny, and it can only host about 15 users with no virtualization. So you can't virtualize your servers. You guys familiar with hardware virtualization at all? Ever run VirtualBox? Okay, that's cool. Basically, in a nutshell, you ever use an emulator?
Yeah.
It's an emulator for an operating system. Basis. We're going to go really deep into virtualization later, and it's a much more advanced topic, but it's essentially an emulator for an operating system. So that's important because I can take one server and turn it into like 15 servers. And I save rack space, I save money, I save time. All I gotta do is purchase more keys. So virtualization is huge inside of networking needs. And inside of our modern day networks too. So it's an important fact to note that Foundation can't support virtualization at all. You can't do anything more with it. It's just there. Typically, personally, I've never dealt with Foundation because I don't know who uses it really. Very, very small companies. And then you've got Essentials, which is exactly what it says, 25 to 50 devices, 25 users, 50 devices can be hosted. And again, no virtualization rights. Standard and data center. I'm actually going to have you guys be working with data center once I get that set up. Data center is going to be the main one because it provides everything, and we're going to be learning off of that. So those are just the differences between the different editions, and data center is massive. And I've actually have some stats for you regarding why data center is so expensive and why it's great, why you should use data center if you're going to launch a huge enterprise network.
Just so you're aware, if you're not already, and we'll be going over this too once we get on the minimum part about servers, is if you have a computer at home, you can install these different operating systems on that computer and mess around with it yourself. And all students at Poly have these, all of them, for free. If you use StreamSmart, you can download any version and use it for free. So if you have one on your part, we'll show you how to get it.
Also, using DreamSpark, you can host that through Azure as well. So provided everybody provides their key, because I would be charged for the key, which I don't want. So provided everybody provides a key, you can host that right in the cloud and log in your server remotely and play with it. So we'll get that set up too. But those are the different editions, and they each cost completely different. Oh crap! Why is that black? Can't see it. That was white on the PowerPoint.
It might be because it's in Google.
Oh, it's in the Google thing. All right.
Yeah, it's a Google thing.
That's fine.
Yeah.
Just do Control A and then make it all white.
I didn't even know there was text there.
Where's
You
wow?
can barely see it. Yeah.
All right,
It's also cutting it off a little bit.
there.
Thank you. I don't know if it's okay. So big table with lots of text. Okay, that's okay. And then so take a look at this. All right. Number of users, foundation, essentials. It changes as we go up. So it did your standard, your data center. You're going to see more in your large scale networks because you're going to need that kind of user support. Guaranteed 100% they're running data center right here on campus because look at all the students we have. We don't exactly have 25 students. We don't have 15 students. All of that. Plus, data center is actually able to support larger servers. All right, that's important because you want your server to have enough power to, shuffle through all the amount of data you're going to be throwing at it and all the data it's going to be putting out. So it can make use of 4 terabytes of RAM. If you can fit that much RAM into your servers, you can do that. Whereas Foundation only allows for 32 gigs, right? And direct access is huge. They almost all use direct access, including Essentials. It's just a silly table. Let's see if there's any other page. The amount of memory that's supported on data center is the big part. That and virtualization. I mentioned virtualization. You can have unlimited virtualization instances on data center. As many as you can support on Windows Server with data center, that's your limit. So that's the big draw to the data center version of Windows Server 2012 R2. So this is just a walkthrough of the GUI install of Windows Server 2012 R2. And you're going to see this a lot. When we get to deploying, let me tell you, when you can take your boss's computer, when he says, oh my goodness, guys, my computer's broken, and you can walk up to his computer, plug in an Ethernet cord, and walk away and know the problem is solved because it just drops a brand new copy of Windows, all his documents get transferred, he's got all his programs. You look like a god, you get paid more. It's all good. That's why I love WDS. WDS is great. So typically, users are never going to see this screen, but for the purposes of this, I'm going to show you what basic install of Windows looks like and walk you through the prompts. So this is the very first portion. It's going to ask you if you want to start with a server core installation or server GUI. Min shell is not an option there. It's underneath. It's a different subsection. We'll get to min shell later, but there it is. All right. It's going to ask you, what do you want to do? Do you want to upgrade the current Windows Server installation, or do you want to do a custom install? Custom install is almost always going to be like, click a disk. It's going to overwrite that disk completely. An upgrade is going to do an in-place migration, so all the documents are going to be saved, and they're just going to be transferred with the new upgrade. So we'll go through there. All right, so this is the custom dialog option. When you click on the upgrade, it skips directly to the next slide. So, but this is what the custom selection looks like. You click your disk, you can format it. You have the option to delete, extend, change all the stuff. You can do whatever you need to. And you can actually get to a command line shell from here and fix disks as a rescue mode as well from the install. That'll go with WDS when we get there. All right, and it's going to install. When you get through it, it's going to ask you to type an administrator password. You're going to confirm that, and there you go. That's installing Windows Server 2012 R2. That's the whole thing. So a couple key terms that I really want to touch on is that the virtualization is a huge portion. When you can virtualize your servers, you're going to notice that a lot of data centers moved from having teeny tiny blade servers, which were powerful, to giant mega powerhouse machines in order to host the virtualization. Because it's going to decrease your costs. Rack space is good. It's just a much better option. So that's installing the server.
How much memory do you need in your computer to install the set? How much is it?
The minimum requirements for Windows Server 2012? That's a great question. I believe that was actually one of the slides on here. I didn't see it. It might have gotten cut off when I transferred it. I had the minimum requirements. It's excruciatingly tiny. What's that?
It's 2.
2? 2 gigs, thank you. I knew I had that slide with all the minimum requirements. RAM, 2 gigabytes.
For certain like services and stuff, like a lot of companies, you heard about virtualization. Virtualization, as I said, is very key because it allows you to take basically some roles, different things that you want your server to do, can't be on the same server with other Windows. So that requires you automatically, if you want to do both those things, to have 2 separate servers. Now, if you have virtualization, you have 1 server with 2 virtual servers on it, and you bypass that issue. So that's why some roles don't require a lot of memory. So you can make a virtual server with very low RAM. So that's why the standard is so low. Because server, especially if you're just using the core, which means there is no graphic user interface, then it's very non-intensive. So like every RAM is very low power.
That is exactly what you run core off of. PowerShell. Another quick introduction to Windows Server is PowerShell. PowerShell is relatively new with Microsoft, and it's essentially a programming language for Microsoft. It's a scripting language that I can do anything and everything with. I mean, I do need everything. When I worked for a company at one point, when we had to terminate users and when they were doing separations, there was a script that went to all the different servers and would terminate and delete that user from the system all at once. Otherwise, you end up with conflicts. So PowerShell is extremely powerful. And in fact, it's so powerful that you can do all your installs and roles and all your feature installations right through PowerShell. And what's great is I would show you, if I had a Windows Server up at the time, is I would show you that at the end of installing all that, it spits you out a beautiful little PowerShell script showing you what you did. So you can save it at the end of your installation, and you can rerun it again on multiple machines. So it cuts down your workload. Very nice. PowerShell is what you're going to run core off of. That's exactly what core looks like. That's it. There is nothing else. So I think that's pretty much it for the introduction, unless you want